GAC, hope you're doing well today. This is Coach Johnson with podcast review number 2 on a Thursday night. Last one we had was on Tuesday night. We looked a little bit over 9.1 A and B. And today we're going to look at a little bit of 9.2. And so we're going to look at that in just a second. I noticed down below that there aren't very many viewers down there. And that's fine, because what we're going to do today is we're going to have an opportunity where we kind of just go through questions and maybe go through some problems. My game plan is to go through at least one. And if you do have any questions, please text me. In fact, there's one viewer there. Fantastic. If you have any questions over 9.2, please make sure to text me. And you can even give me a picture of the number, or you can give me the number. You could give me a picture of the problem. Whatever you desire to do there would be helpful for me. We're looking at 9.2. However, if you are still struggling on 9.1, feel free to put those questions out there, and we'll go through those together as well. So again, that's what we're doing, and there you're at. Right here, this is a picture of my daughter. She cracked me up. Today she gave my wife this look, and so I just tweeted it out. I don't know what she's doing, but man, I love her to death. But let's do this. Enough of just my daughter here. We're going to get on with the problems. These are the problems that you notice that are on the side there. And as you go through them, if you've got a question on one, throw that out there and we'll get it rolling. So I'm just going to give about 20 seconds to get a question out there. And if no one has one, then what we'll do is we'll do one together. I actually see two here. We'll do one on the top, and then we'll also do one towards the bottom. Okay? All right, so I'm going to hold up just a second. Just going to wait. And again, if you have one out there, throw it out there. Throw that question out there. While you're doing that, I'm going to start writing these down. Put that center down there. We have the radius. Sometimes we don't always have a radius. We're going to look at that today. Vertices. Foci. And eccentricity. Okay. Really, eccentricity, we can look at that. You can actually look at the answer sheets. I believe it is C over A. I believe that's the case. I think it's A over C. I always forget, but that will be on your formula sheet there. In fact, I'll look it up just so we've got it here. While people are throwing out questions out there on the podcast, I know we got tons of people from Sweden. Welcome. People from across the globe in Russia and in Tajikistan, and all over the place. And so again, if you are a part of that, thank you so very much for being here. All right. All right, eccentricity, I was actually right. It's actually C over A. Okay, C over A. And so again, it actually was right. C over A is what that formula is, okay? Notice this too, that the foci, to find the foci, it's C squared equals A squared minus B squared, okay? All right, perfect. And if you're not hearing me, please make sure you throw it out there and we'll rock and roll. All right, let's do the first one. In fact, let's do number 3. No, let's do this. Let's do the first one, and then we'll go to one that's towards the bottom. Okay, so let's do this. Number 1 kind of gives it to us in standard form. Now, we're going to determine whether this is a circle or whether it is an ellipse. It's kind of what we're looking at as we compare. Now, the big thing to kind of note is this. If the bottom is different, then we can assume that it's an ellipse. Whereas if this is the same, then what we'll have is a common radius. My major and minor axis will be the exact same. So therefore, it will end up being a circle. You could actually multiply left by 9 and then also do the right by 9. And that would get that value that's there, okay? So let's look at the first one. Maybe this will help us, and we'll go from there. So we know that this first one's an ellipse. We know the second one would be more of a circle. The key with the circle is that you would have a center and a radius, but nothing else. Whereas with an ellipse, you would have no radius. So in this first one, we would have no radius because we'll have an ellipse, again, because it has different, does not have one common radius that it rotates about. So the first thing to do is we look at what the center is. Notice that in the first one, our center is at 0, 0. Whereas maybe on the third one, you can notice that this would be like 4 to the right and 3 down. So my center here would be like 4, -3. So that would be a different center compared to the first one. So my center here would be 0, 0 because it has just the x squared and the y squared with no transformation there, okay? All right, perfect. Now the next thing we do is we determine on the x-axis where are we rotating. Well, as we look at it, as we see it here, what we have is it's not 81. We actually have to take the square root of it because our standard form would be x squared over a squared plus y squared over b squared equals 1. Notice that the a will always be the greater value. It will always be the greater value. That's very important, and it's always underneath the first one or the highest one there, okay? So it's always the higher value that's there. I guess it couldn't be the first one. Sometimes it might be the second one, like this. But in this case, a would be, or a squared would be 16. So if a squared is related to 144, a squared and 144, because it's the higher value, okay? So actually it should be, in this case, b squared and a squared, because again, 144 is the higher value. Now we know that a is equal to, or a squared is equal to 144. So a, if I were to square root both sides, a would be 12. We'll talk about that in a second. Now, if I square root the 81, b would be 9. So the only difference between a and b is a is the higher value, whereas b is the lower value. So as I graph this, what we want to do is see at the x, I am going, again, since the b is underneath, I'm going to go 9 to the right and 9 to the left, okay? 9 to the right and 9 to the left. Now, in order to kind of simplify this, we're going to say these are going to go by 2. So 2, 4, 6, 8, and 10, okay? That way we can kind of, that way we can kind of fit this. Otherwise, we're not going to. 2, 4, 6, 8, 10, 12 will be up above, and then it obviously goes down below. So on the x-axis, since the x corresponds with 81, and we take the square root, that b, or the 9, tells me I'm going to go left and right 9 because the 9, or the 81 rather, is underneath the x, okay? Since the 144 is underneath y, we're going to go 12 up and 12 down. So it should look like this: 9 to the right, okay, and 9 to the left, up 12, and also down 12. So what we have is this. We have this graph here. This is kind of our graph here. This is our ellipse. The reason why it's an ellipse is because it does not have a common radius. Again, a circle with a common radius that rotates about, that has a common radius there, that's a circle, whereas this goes 9 left, 9 right, 12 up, 12 down. So no longer do I have a radius, but I have what's called a major and minor axis. In fact, if I were to ask you how long is the major axis, you would just tell me 24, because it goes 12 up, 12 down, but the total distance is 24, and it's on the y-axis, or because, again, it's underneath that y value. Now, my vertices are always the ones with the major axis, so because the 12s are greater, we'll say the vertices are at 12, 0, and -12, 0. And that's how we kind of write that right there, those vertices, okay? Now, the eccentricity, we're going to come to at the very end. Remember, that's the formula. But with the foci are always inside of the major axis. So they're somewhere in here, okay? So it doesn't have to be exact right there for right now, because we're going to solve for it. But if we were to put 2 pencils here and here, and, or I'm sorry, if we were to put a piece of string with a pencil on it, that rotates here, and we were to rotate this around, this ellipse is what would be created from these foci. So just kind of giving you an idea. So to solve for my foci, simply do c squared equals a squared minus b squared. So we know that c squared, we don't know what that is, so we're going to say c squared. And then we'll say equals a squared, remember the a is always the higher value, so this would be 12 squared minus b squared, so 9 squared. So really we have 144 minus 81 equals c squared. So when we do 144 minus 81, we get 63 equals c squared, okay? And when I square root both sides, my answer will be c equals plus or minus the square root of 63. Now you could leave this as is, but in fact, it's actually better. I would either do it as a decimal or I would keep it in the square root. And a lot of times, for instance, on the test, I'd prefer to keep it in the square root. So my factors when multiplied of this would be 3 times 3 times 7. Okay, we have a pair of 3s. We bring a 3 to the outside. So it's really plus or minus 3 root 7. So you might say, well, Coach, what does that do? What does C do? Well, what that means is from my center, I'm going to go down negative 3 square root of 7. And I'm also going to go up positive 3 root 7. Okay? So what we can do is this. With the foci, we could say it goes up and down. So the x stays the same. So we say 0, 3 root 7, 0, negative 3 root 7. And so again, that right there would be our foci for that value. You could keep it as a decimal. That would be sufficient too. But again, that's kind of what we're looking at when we talk about our foci. It makes it really easy to translate it because the center was 0, 0. If the center was at 4, negative 3, what you would do is say negative 3 plus 3 root 7 and negative 3 minus 3 root 7. Because again, we're talking from the center is where the foci are translated. And remember, it goes on the y because that is our major axis or the greater axis. Now, the eccentricity tells me it kind of deals with like planets, and we won't get too much into it. It's just kind of a question we want to make sure we know. We'll go more into it maybe even when I get back there. But the whole idea is we put 3 root 7 on the top, and on the bottom we put a. A would be just 5, right? Or hold up, not 5. I'm sorry, I looked up here. A would be that 12 there. So when I do 3 into 12, it'd be square root of 7 over 4. That's eccentricity, and that's kind of what we're looking at there, okay? Really not a big deal. I don't think that's on the test, the eccentricity part, but I just want to make sure you got it there, okay? All right, perfect. Hey, I do have one more viewer. I want to make sure that I have not getting a text message. I forgot my phone inside. Take a look at that one. We're going to look at one of the ones on the bottom there in just a second, okay? I'll be right back. All right, perfect. I don't have any questions yet. Awesome. Hopefully this is just a good review, okay? So let's go. Let's do this. Let's erase this one. Okay. All right. Let's go through. Oh, man, this one's a good one right here. Let's go over the one that's the number 4, okay? A little bit tougher, okay? Let's label this out. Let's go. Perfect. Let's go 9x squared. Let's put all x's together, okay? So 36x. And let's put all y's together. So let's go 4y squared. So we're going to leave this here. So let's go plus 4y squared. All I'm doing here is just putting the y's and the x's together, okay? Minus 24y. Perfect. And this whole number, let's subtract 36 to the other side, okay? The reason why we're doing that is we're trying to get it into a standard form. Right now we don't have one there. So we're trying to get this into a standard form. Now I'm going to take this extra slow because on this next one, we want to try to see, is there something in common that I could take out of both the x's and the y's separately, okay? Well, I know that 9 goes into 9 and 36. So if I were to take it to the outside, I'd be left with x squared plus 4x, okay? Leave it there. Now with the y squared and y, we could take out a 4. Keep that positive out there. We're left with y squared minus 6y. And I'll keep this negative 36 on the right. Now the problem is that, remember, we have to get something that is a perfect square. And that's where it becomes a little tricky. So we've got to take a step inside of both the x and y to determine, is there another value that when put in there would create a perfect square? Well, remember, completing the square is a method we use to solve a quadratic and would be the same one that we can use here to be able to solve for the perfect square. So what we're going to do is we're going to take the middle value, whatever one is just with the x and the y. We take that value and we half it, and then we square it. So I'm going to take 4. You can't see that. Let's do this right here. Take 4 and half it, getting 2, and then square it, getting us 4. So what I'm going to do is right here on the bottom, I'm going to put 9 parentheses, x squared plus 4x plus 4. Now, if I add 4 to the left side, you think, oh yeah, I've got to add 4 to the right side, right? With this negative 36. But because there's a 9 out here, you're really not adding 4 to the left side. You're really, again, because it's distributed, right? We don't need to distribute right now, but if it was, you're really adding 36 here. So if I add 36 on one side, got to give some love to the other side. Perfect. Now the next part would be the plus 4. Okay, get the plus 4 here. The question now becomes, what do we do with this negative 6? Well, we do the same thing. Half it to get to negative 3. Okay, half it, negative 3, and then we square it to get positive 9. But remember, I'm not really adding 9 to the left side. I'm adding 36 because 4 times 9 is 36. So really, we got to add 36 again. So we're left with y squared minus 6y plus 9 on the left with all of this mess on the right-hand side. Now, once I get this simplified, you'll notice that negative 36 and 36 cancel, leaving me with just a positive 36. Over on the left side, we get 9 parentheses. What two numbers when multiplied get me 4, but when added get me 4, it would be x plus 2 and x plus 2. Over on the y side, what two numbers when multiplied get me positive 9, but when added get me negative 6. Remember, that would be negative 3 and negative 3. And if you did not get the exact, if you didn't get a perfect square to where we've got two things that are the exact same, you did something wrong on the previous step. You need to go back and check that out. Now, my last part of this is I got to get this to where this is equal to 1, right? Because that's standard form, right? We need it equal to 1. So I need to divide by 36, but what I do to one side, I do to the other. And I've got to do to both of them. So the simplified version, 9 goes into 36 4 times. 4 goes into 36 9 times. So I'm left with this, x plus 2 squared all over 4 plus y minus 3 squared all over 9 equals 1. Now that looks a little bit better, does it? Now, I'll tell you this, that's not easy. Going from step 1 to 2 to 3 to 4, and then finally to my answer where I'm not even, all I've done is set myself up for this problem. I know that that's a little difficult. It's a little tricky. And we're gonna have to do a few problems off that, and I know that. But as far as everything else goes, I think we should be good to go on that. All right. So we'll just keep this as is. So my next thing is, what is my center? Well, my center is going to have the transformation of x and the transformation of y. So this would actually be opposite. So this would be negative 2, comma 3. Negative 2, comma 3. That's the center. Remember, opposite. We're thinking opposite, right? So remember, just like we would transformations, if it's in the inside of a parenthesis, we think opposite, both left and right, both up and down. Now, finally, actually, let's do this. Let's graph it too. So we have negative 2, comma 3. So we're going to put a center right there. We also know that in this case, we'll just do each one as one value here because we got small enough. We got to determine what is A and what is B. Remember, A is the larger one, whereas B is the lower one. So A squared equals 9. whereas b squared equals 4. So when I square root both sides, I get a equals 3 and b equals 2. Okay? So as I focus in on this, notice that the 2, or the b, is underneath the x. So from the center, we're going to go right 2 and left 2. Again, because the 4 is underneath the x, we think left and right. The square root of 4 would be 2, so we go left 2 and right 2. Now, since the 9 is underneath, that is the a, we know we're going to go up 3 and down 3 because it's underneath the y. So we're going to go up 3 and down 3 to where my graph should look something like that right there. Now, the major axis would be the distance of the larger, well, it's the larger axis is really what it is. And since the a is 3 going both up and down, my major axis length would be a total of 6. If I asked for that, I probably wouldn't, but if I did, yeah, you know how to do that. My vertices would be at -2, 0, and -2, 2, 3, 4, 5, 6. -2, 6, okay? Those are our two vertices. Last but not least, let's find our foci. We find our foci by doing c squared equals a squared would be 9, okay, because again, that'd be 3 squared, be 9, minus b squared, which would be 2 squared, which would be 4. So c squared equals 5, or if I were to square root both sides, c is equal to plus or minus the square root of 5. Now let's hold up for a second. I want to make sure that you understand what's going on. Again, making sure we emphasize c squared equals a squared minus b squared. Remember, the foci are somewhere within the major axis. It's on the major axis inside of my vertices somewhere. So in order to determine that, we take our center, which is at -2, 3, and we'll translate this up and down because it's on the major axis up and down. Sometimes it's left and right. If the major axis was the x-axis, it would go left and right. But with the c will actually affect the -2, 3. So my foci points should be -2 parenthesis 3 plus root 5, okay? Because what it did was we take, this is the point, and we go up root 5 and down root 5. So then we'd have -2, 3 minus root 5. And so those two would end up being what my foci would be there, okay? And again, that's kind of what we're looking for. Eccentricity, again, we do c over a. C would be square root of 5. A would be 3. So square root of 5 over 3 would be our eccentricity there, okay? Hey, I hope those were helpful for you today. I know that we hit on just a few, but I think that, you know, those are two homework ones that I think will be beneficial for you as we talk through those. Again, if you have any other questions, please let me know. I do see one viewer here. If you did view that, I would love for you to text me. That way I could kind of ask you whether it made sense or not, and see if I could do any other questions or anything else to be able to better prepare you. Hey, tomorrow's the last day that I'm going to miss. Next week, I can't wait to see y'all again. I've missed y'all. I've enjoyed definitely seeing my daughter, but at the same time, I've thoroughly also enjoyed, I'll enjoy getting back to it and getting back to seeing y'all as well. I care about y'all a lot, love y'all a lot. Anything I can do, please make sure, text me, let me know, and we'll go from there. Thank you all so much. Have a great day.